My name is Maksym Polyakov from School of Agriculture and Environment and SIP and CRC for water sensitive cities, and I will be presenting work in progress which is called Does Local Councils' Involvement in Planning of Infill Development Generate Benefit to the Residents? And my co-authors will be Said Iftikhar and James Fogarty, and we do this work within CRC for water sensitive cities. And the answer to this question, yes. So you can go. But if you want to know what does it have to do with the water sensitive city, you can stay and listen. So, and I'll go from afar, start from afar.
Do you miss anyone in the office list update? No.
Unless he, yeah, we could add. It's never late to add people. So, just a few days before, I was looking at what is like housing density or population density in cities, Infill. I come across data about population density in cities in the world, and there's about 1,000 cities, biggest, more than 500,000 people. And this graph shows distribution. On the x-axis you have population of city, millions, and the y-axis you have population density in thousands per square kilometer. Okay, and colors show regions or continents. So green is Africa. You can see that you have higher density in Africa. You have in Asia is gray. You have high density in Asia. You have high density in South America. You have medium density in Europe, and you have like low density in Oceania, which is Australia and New Zealand. There are 6 cities only, and bipolar by model distribution in North America. So this is Australia and New Zealand. So you have Gold Coast, Perth, Brisbane, Sydney, Melbourne, more or less very low density, about close to 2,000 people per square kilometers. Okay, so this is kind of background for this, and you see that it's similar in North America and Australia, but like quite different in other places. And this is these are several snapshots of what the density population in some of these cities in Australia and few more. So blue is kind of between 1,000 and 5,000. Dark blue, you see in Melbourne, this is Melbourne, as you could guess. There are in central parts a little bit red, which is like 10,000, 15,000 per square kilometer. This is Perth, quite low density, all blue, not even dark blue. This Adelaide, also low density relatively. This is Singapore, completely different story, like maybe 5 or 10 times higher density. And this is, anyone guess? Manchester. You have much higher density. I wanted to make a picture or calculate like if you would have Perth density and you would spread English population or British population into whole Britain, whether you will have like whole country covered by one big city, but it's not quite. You just fill half of UK. So Australia has growing population, and population is projected to double by 2061, and 3/4 live in cities, and there are 2 approaches to grow, to accommodate this growth, and one is greenfield development, and another is infill development. And greenfield development is just to go outside of the city and build new suburbs, which is called urban sprawl. That is something which is called that picture where you have in North America and this is Perth. North America and Australia, where you have very low density of population in urban places. And so the negative things of that, obviously everyone has backyard and big backyard, but the negative thing is that public transportation is very inefficient, and all the utilities are very inefficient. And basically most of the cities and urban places in Australia and or Australasia and in North America, they rely on cars, and there is no walkability, no public transportation, high carbon emissions, everything bad. Okay, so alternative, there is a way to, and then people or planners look at there are other ways to accommodate growing population, and that's through infill. So there are a lot of properties which have big sizes close to the center. In Netherlands, you have like 800 meters lots, for example, and like it's possible to subdivide and accommodate more population in those places. So this is another trend or approach, and all Australian cities looking at this approach. So in this example shows small scale kind of infill when you look at properties which have big lots in the central parts, and you split into 2 or 3, or build like townhouses. And then another example, this is from our case study, which we'll show in Salisbury. So they have also bigger, they call infills. And we might discuss why do they call this infills. This one in place of school. So one picture is about 2010, another picture is 2018. So they built some, and this is within city boundary. So they have big area school, probably they build new school, and they build new, or allocated to new development, and they have much higher density development in surrounding. And also there could be some like greenhouses or fields. Within city, they still call it infill because that's within city boundary. Okay, so in all the cities in Australia, or capital cities in Australia, has some targets of, because they know how population will grow, targets of how many new dwellings do they need to accommodate that population, and also they have targets of what percentage of that new dwellings will go through infills. So you see that 60, 70, 50, 47 Perth is lower, but also time frame is different. So they're not completely comparable. And Adelaide has higher target than, for example, Perth. And probably that's because they have the target they call also, if you have field, agricultural field within cities, they want to call it infill. Okay, so and then negative things. So with infills, you could achieve not very spread cities. You could be more compact. You could easier provide public transportation, utilities. You could have walkable suburbs, but the negative impacts of infill is related to water. That's why water-sensitive cities. So in general in cities, especially if you have higher density, you have increase in impervious surface, and that's very important for the health of waterways and for groundwater. When we have a lot of impervious surface, you have higher water runoff, and water immediately after rain gets to the river and it carries all the bad stuff with it, and like the groundwater doesn't get replenished, and you have loss of green space when big lots, for example, in Netherlands have a lot of trees and green space on the backyards, private green space. With infill, there is no space for trees at least. You can have some green space, but not much. So, and then you have to rely on public open space and streets, green space on the streets. So these are examples in Adelaide, where is our case study. This is infill, and basically everything is concrete. There is no pervious surface for water to be almost no. Okay, and this is a good example of infill, again, in Adelaide. And this is like one example when council, well, at least they tell that council was involved in development of this, in planning of this infill. And you see not only you have some soil or mulch where water can go through, also this path which is shared with, okay, it doesn't show sign, but path shared with like pedestrian and cars, it's pervious surface. So water can be absorbed by the soil, not everything goes to run off. Okay, so and then this is study within IRP2 Integrated Research Package 2 of Water Sensitivity Tranche 2. There are several packages, and one is case studies, and package 5.4 and 5.5 is urban development case study in Adelaide and Melbourne. And we have methods, economists have methods. So we try to how can we apply our methods to solve problems. And we will use two methods in relation to infill. Together with architects develop a set of designs or design options which would be more water sensitive. In one of the study which we will do which we at the moment implementing with Said and Abi, is to look what the people's preferences for different housing options in context of urban infill, and those which are, some of them are water sensitive, and in particular it was surprising for me the garage option is very important or parking option is important for infill to make it more water sensitive as far as you have garage, for example, you add a lot of impervious surface, and if you have street parking or you have parking on the in another option with pervious surface, that would be better. So, and there are other options. And then other study, we will look at what is the benefits of local councils involved in infill planning and implementation in Adelaide. So first one is in Adelaide and Melbourne, and second one is only Adelaide, several local councils. So what is this like involvement of local council in infill planning and implementation? So obviously if someone is an infill subdivision or any developments they have to follow some rules and regulation, zoning and council vision or plans or residential codes. Okay, so and then council enforce that. They make sure that application follows these rules. But in addition to that, that's not necessarily will provide water sensitive outcomes and environmentally friendly outcomes. So in some cases, council try to work with the developers to achieve better outcomes, and it's just they have to by following these rules. So they work with developers, and obviously if it's development subdivision of 1 to 3, there is no, first of all, there is no scope for the developer or proponent to do much, and second, for council it does make sense. But if there are bigger developments, there is more likely that council can put some kind of effort and achieve outcome which is both water sensitive, environmental sensitive, and better maybe design and planning of communities. And we assume that in this study we assume that if council does get involved with the developers then, or those who implement subdivisions, then outcome would be better for water sensitive, and it's also environmental, and also people would like it more, and they might get benefit, and that benefit would be capitalized in house prices. And so basically the assumption is if council is involved, house prices might be higher. So this is what we try to do. Kind of indirectly assess what is the impact of council involvement. And this approach idea came from council. When we tried did several meetings and tried to see how can we measure this, they suggested that this would be one of the way which you can measure, assess, I guess, water sensitive outcomes. Yes, but we cannot, like, it would be nice if we can measure, and it's not necessarily a hedonic model. I mean, it will be not hedonic if we can measure, but not everything can be measured. So, and then we use hedonic model, and we assume that price, as usually, like everyone knows here, that price of the house consists of prices of its components and features, and its characteristic of house, number of bathrooms as usually, size of the infill subdivision. We have to control for that, like because of if it's bigger subdivisions, then developer have potential and scope to do better jobs than if it's like 1 into 3, when you have like this hammerhead infills. Also location characteristic, obviously that's very important. So how far it's from the CBD. If you have far away, then it's cheaper. If you have close to parkland, it's more expensive or more valuable. And also the variable of interest would be better infill design. Well, we assume that it will result in council better infill design, result of council's involvement in planning would result in, we hope, higher values for buyers and higher prices. So our case study is Adelaide. And we started from the city of Salisbury, which was interested in this infill. It's kind of a little bit on the edge, but not outside of the urban, I guess, growth area. And it's a little bit depressed, and they were interested in do some planning which would have uplift. So we started.
Where's Salisbury there?
I'll show. Okay, blue is Salisbury, and then so we started with Salisbury, and then Melissa Bradley, who is water sensitive SA, who is really excited about this project, and she convinced 2 other councils to participate. So Port Adelaide is urban, and Iringa is on the south of Adelaide, but half of that is not in the metro area, like as defined by last census. Because previous census is defined by the boundaries of LGA, and this one is more kind of precise. So there is kind of rural areas. So they, in consultation with City of Salisbury, we developed this classification. And we have 3 types of infills or subdivision development. One is when there is no input or limited input, when they just developers just follow the rules, the council development plan and zoning and residential code. And specifically for smaller subdivisions, that would be, or infill, that would be the case almost always. And then the medium or preliminary input when council want to achieve some better outcome by kind of advising or convincing developer to do better connectivity to public open space, have better road network layout, and have some better than required stormwater infrastructure. And then there is high level of input when they also accommodate some of the, I guess, requirements or I mean, wishes of the developer. They may rezone, and they incorporate this development into council's development plan, and also they could have some input into what kind of dwellings developer would be implementing. So, and then we asked, okay, so this is map of these councils. So on the left hand side you have Adelaide, and then in the middle you have 2 Salisbury and Port Adelaide, and on the right hand side you have Iringa, and then the colors show, so gray would be metropolitan area, greenish fill would be residential code, and then dots would be, black is just infill, which is not, there was no additional input from the council, and green would be, you have preliminary or medium level of input from the council, and high would be, red would be high level of input from the council. So we have this classification. How did we do this? We got a data set of subdivisions in the state. We identified all the subdivision, and in this map, land division applications, with those which were approved after 2000, show green color. So we gave it to the council, and councils draw basically those subdivision application or infills where they provided either medium or intermediate or high level of input, and worked with a developer to achieve their whatever target outcome. So they show red squares would be high level of input, and they're quite big development, and again, mostly that would be bigger subdivision, and bigger means that in how many dwellings or how many lots were as a result of this subdivision. And they insist all of them are infills. Okay, but some of them, all of them are obviously within city boundary, city growth boundary, but some of them were, there was some agricultural land or parkland or in some case school in the middle of the city. Okay, so Do you have questions so far? So we have this data set where we have subdivision applications, we have cadastral data set, we have information about whether there was input from the council, and we took as a sales of, we got data set of property sales, which was about 50,000 sales in those three councils, but we selected only those which were sold after 2000, after subdivision application, after infill. So we came up with about 12,000 observations in about 3,200 subdivisions. We used houses and units. Obviously, that would be only residential subdivisions as purpose. Houses and units. About 10% of those house and unit sales, not subdivisions, sales were classified as preliminary input, and about 25% or 24% of those were of sales were classified as high input or in infill subdivision. And if you look at the subdivision application, obviously that would be much smaller number because they usually went to larger subdivision as measured by number of dwellings. Okay, so this is, I didn't provide more information about data, but this is density graph of 3 different types of dwellings by level of input from the council. And on the x-axis there is a price, and on the y-axis is density, and there are densities separately for each of those classes. So you can see that those with limited input and preliminary input, so-called, they are the median prices would be about less than $400,000 in 2019 dollars. And those which had high input, which is greenish, have a little bit higher, like it shifted a little bit to the right, to the higher prices. And median would be about 425. But also, this doesn't take into account that we have everything is different, and the location is different, and sizes of subdivision are different. So those which high input would be probably higher. I mean, not probably, definitely would be bigger subdivisions. But in regression, we'll take into account that. So we do model with year fixed effects to control for dynamics of housing price if we have 20 years or 19 years of data. We have suburb spatial fixed effects to account for that in different locations within metro area. Prices are different because of locations. And also we have error clustering because within each of those suburbs, within each of the subdivisions, there is something common between dwellings which are built in one subdivision. And so we also do robust standard error. So log, depending variable is log of the price. Not, I did not deflate price because we use temporal fixed effects. So we have dummies and we have continuous variables. If it's dummy, the coefficient of this variable would be interpretation is a percentage increase in house price when variable is 1. For example, for high input, it's about 2.5%. I mean, 0.025 is a coefficient, and the meaning is that the dwellings which are built in subdivision with high input are about 2.5% higher price. And if for continuous variables, it's elasticity, because we also, all continuous variables are logs. So this is graph. I don't show table with data. Point dot and whisker graph, and dot is a coefficient. On x-axis you have coefficients, and whiskers would be 95% confidence interval of the, and first part of the variable. So on the left-hand side you see variables, and first bunch of variables would be characteristic of houses, and you look at log of lot area, so you have elasticity with respect to lot area. House age, so bigger lot, higher price. older house, lower price. Units are cheaper than houses. Multi-story houses are more expensive than single-story houses by 12%, holding everything else equal. Number of bedrooms, more bedrooms, higher price. Bathrooms, same thing. Car parks, more car parks, higher price. Brick wall somehow is cheaper, I don't know why. Tile roof doesn't, it's just to control for all the variables if you have, doesn't have any impact. Distance to parkland, important factor, it's about 0.01 coefficient. So if you go far away from the park, price is cheaper. So elasticity is 0.01 with respect to distance to park. Closer to park, and it's very highly significant. Okay, how did we define parkland? This is very crude definition of parkland. A census of population has mesh blocks, and each mesh block, there's the smallest unit of census, and each mesh block has classification of land use, and some of them has classification of parkland. So we use that one because, and that wouldn't include smaller parks or pocket parks, just bigger ones. So residential code is basically it's different land use. So if it's residential code, there are more strictly standard, I assume, and the prices would be higher. And about 85% of all observations fall within residential code. And then size of the development is measured in number of dwellings in the development. So elasticity is 0.01, sorry. So bigger, if you double size of subdivision, your price increased by 1%. And now finally, variables which we are interested in, preliminary input, council's input, and high input. So preliminary input is about 1% coefficient, and it's not statistically significant. And then high input about 2 and 7% coefficient, and it's statistically significant. This says that controlling for all other factors which we have, which you could think of, including size of development and proximity to park and time and location and structural characteristics. If there was high input from the council into development of this infill, they call infill, the price would be by 2.5% higher than if they wouldn't be involved in this planning of subdivision or infill. Any questions? Yes.
You have brick walls and tile roof in addition to the price cell.
Yes.
Isn't that something that's contrary to what most people think? Does it have anything to do with the fact that most of the new houses might be non-brick or prefab, so this is because of something that's missing in the model? Is that possible? Why would a brick wall be cheaper?
I don't know. I don't want to explain that. I mean, I just wanted to control for that. But thing is that I know that brick wall is, if brick walls, it's much, so it's very problematic, my experience, my perception. Like if you want to put nail into the wall, or you want to do something, or you want to do like some structure, like pipes inside, it's much harder to do than if you have like gyprock. And also insulation could be a problem. That's what you see. In Perth, it could be actually opposite, but this is Adelaide.
What's the alternative? They've got two categories, brick walls, and then the other.
Everything else.
Including concrete.
Well, there are many, not concrete, but there are weatherboard and there are other. Okay, if you're interested, I could look up what are. There are like 10 different classes. That's why, and brick wall is like approximately half of the would be brick wall, and there are other. Yes. Yes. But I control for age. So, and these are only built after 2000.
Oh, okay. All right. I was just thinking, because Adelaide has a very strange mix of housing styles over time. I wondered if that might be.
It's built after 2000.
But nothing else about the characteristics of the infill in terms of any other design characteristics as to what's gone into it. There's nothing about whether or not
That's what the high input is a proxy for.
well, it's a proxy for it, but you've got nothing that's I think a problem.
I was looking really hard to see if I can like spot differences, but I didn't. For example, you could see how much is of green space, but then like data is, if something is 2001, you wouldn't find a picture. Yes.
Primary, there are primary entries that you input, right?
Yes.
But I'm highly suspicious these variables are endogenous.
Yes, that could be.
You know, wealthy council are paying high council rate. I'm expecting the infill development.
Okay, are you talking about different councils?
No, I mean, if I'm coming from a highly priced region with good facilities and paying a high council rate, well, where does the money goes? And I'm expecting that.
Okay.
Have you thought about the direction of causality?
Yes, but that's, yeah, exactly.
Okay, so let's talk about direction causality. No, I know that's the problem.
Are you into full open questions at this stage?
Okay, let's look at a few more slides. I know this is a problem. So the model explains about 70% of variation and in log of house prices. So we close to parklands have higher prices or values. In larger infills, they have higher values. Medium of input of council involvement may have some positive impact, but not statistically significant. High input have impacted about 2.5%, and it suggests that, may suggest, unless I'm completely wrong, that if council get involved to do some better job, to make developers do a better job as far as green infrastructure, water-sensitive infrastructure, then residents also benefit. And like if you would aggregate this result, we get 30 million, the impact of this involvement on those three councils. Okay, if we believe in our model and results. And we have sorry? We just capitalized value.
Capitalized value.
Yeah, and it's in 2019 prices. So it's how much land or homeowners captured in value of this input over 20 years.
If you believe in the direction.
Yes. So, and then I tell that there are potentially problems. We control for everything, but for example, it could be that locations that, for example, council knows that this is valuable area, and they would have input in those places where prices would be high anyway, and we don't know. But we control for suburb. Okay, so. And then what is the cost? That potential new question. And then it's possible that if you can measure this by other means, or we don't have to bother about input of the council if you could measure like green infrastructure in those developments or infills. Okay, and then help of this. It would not be possible to do this analysis without Melissa, who was like instrumental into actually initiating this, and Amanda Berry, Clint Watchman from Salisbury, who provided data, Heidi Lasses from Iringa, and Tony Kamenjan from City Adelaide.